Okay, so we've talked about different types of reactions. We talked about synthesis reactions, we talked about decomposition reactions, combustion reactions, and then the last thing we talked about was single replacement reactions. Okay, so at this point, one of the things we can do is we can actually look at those single replacement reactions and determine whether or not they'll occur. Okay, and so what we'll do with that is we'll use something that's called the activity series. Okay, and so the activity series is a series of elements that have similar properties and that are arranged in descending order of chemical reactivity. And essentially what that is saying is that looking at metals, there's metals that are more reactive and there's metals that are less reactive. Okay, so if that particular metal is more reactive, then it will displace another metal in an aqueous solution. All right, let me show you what I mean. Okay, so here's the activity series. It's in descending order. So if I am trying to determine whether or not a metal will displace another metal. So, and I just want to point out too that you see hydrogen there. Well, that hydrogen is telling you, will you get an aqueous solution from those elements? Okay, and if these metals are above hydrogen, then you will get a reaction. Okay. So, and the least reactive you usually found in a free state, so by themselves, and they don't react with acids. Okay, so anything above hydrogen will react with acids. Okay, let me show you how we use this. So before I go any further, let me just emphasize the aqueous solutions. So we talked about the different states of compounds and elements in a chemical equation. So we have solid, we have liquid, we have gas, and then the last one we talked about was aqueous solutions. So an aqueous solution is a solution with water, and it could be anything. So whatever it is, it's dissolved in water, okay? So in terms of these aqueous solutions, the reactions that occur, if I take a metal that is more reactive than hydrogen, so if you look back at the list, let's say I take magnesium, and I add magnesium to water, okay? If that magnesium is above the hydrogen, which we know that it is, then it will react with the water, okay? And that hydrogen will get displaced, so you'll end up with a metal hydroxide and hydrogen gas, okay? So an aqueous solution occurs when you have a metal reacting with water, and that particular metal has to be above hydrogen on that reactivity series, okay? All right, let me give you an example, one example of the way we can use that activity series to predict whether or not a reaction will occur, and then if it will occur, what it will look like, okay? So here we have magnesium, and we're taking magnesium as a solid, okay? And then we have the lead nitrate, which is in an aqueous solution, okay? And then we want to know, well, is that going to happen? So the question mark. So we have magnesium and we have lead metal, okay? So we're going to go back up to our activity series, which is right up here, okay? And we said magnesium, which is here, and we had lead, which is down here, okay? So the question is, if you react that magnesium with lead nitrate, will a reaction occur? And if it does, what will you get? Okay, so we go back down to our problem and we look and we say, okay, we know that magnesium is above lead nitrate on the reactivity series chart. Okay, so that means is that this magnesium can displace or replace that lead, okay, and push the lead away from the nitrate, because that's a more powerful reaction. There's a greater reaction because the magnesium is higher on the activity series, so it's more reactive. Okay, so we just did this. We checked the series to see which one was more reactive. Will a reaction occur? So in this case, here's what we would get, and we would predict this because we should be able to at this point. So we know magnesium is more reactive than lead. So that means that the magnesium is going to push lead out, right? And then lead's going to be all by itself over here. And then what you're going to get now is, because the magnesium has taken the place of lead, now you get magnesium nitrate, okay? And so what you've gone from is solid, AQ, AQ, and then solid, okay? So that is a perfect example of our single replacement reaction. The last thing we would do, and oftentimes what you're going to see from now on is you're going to see a lot of those descriptions as we identifying the states, particularly when we're doing these kinds of reactions. The very last thing you would do would have to balance the equation, but in this case, this particular equation is already balanced. Okay, I'm going to stop there. I have a couple of short videos to reinforce what I've just covered with you. I have a Google form for each of the videos for you to complete as or after you watch the video. We're going to meet on Wednesday, so you have a couple of days to do both of those assignments. We'll meet on Wednesday. They should be turned in by Wednesday. I'd like to go over them and like to look at some more sample problems and give you some of those to do on your own. Okay, so that's it. I'll post it and you can take the notes and then watch the videos.